our session for today. We're gonna cover paper one, but today we probably gonna answer all the questions for Form 4 topics. So let's start. Basically, previous video we discussed on the structure of the paper one exam, how it's laid out in the exam, in the real SPM, how the topics are arranged, and how much of the question is the most focused on. Basically, is the force emotion. It's the most number of questions that will be asked in paper one. So it's logical because force emotion is quite long, the topic itself. So beware about that. So let's start with question number one here. This is from intro, topic intro. Okay, which of the marks right combination explain the correct scalar quantity or vector quantity? Okay, so if it's scalar quantity, it must have magnitude, doesn't have direction, doesn't mean it base quantity, and doesn't mean that it must be derived quantity as well. So this is not correct. Okay, scalar quantity, magnitude, this is wrong. This is wrong. Okay, vector quantity, direction, must have magnitude as well. So this is not vector quantity and derived is not. Doesn't mean it's vector quantity. Magnitude, direction must have. Base is wrong. Derived also wrong. So here we see that the question really don't ask us about what specific the scalar quantity gonna be. But what we can do here is actually all base quantity is scalar quantity. So we can make it right here, but doesn't mean that all derived quantities are scalar quantity, right? But in this case, some of the derived quantities are scalar quantity as well. So what this question is quite complicated in the sense of the layout itself. So basically, it says that if the quantity is scalar quantity, it has magnitude, it doesn't have direction. It can be base quantity because all base quantity are scalar quantities, and it also can be derived quantity. So we can translate the question as that maybe. So maybe it has derived quantity, or maybe it has included the base quantities, but basically all base quantities are scalar quantities. So if we can think it like that, then this is correct. A is correct answer. So let's revise our answer for the rest. Scalar quantity. So this one is correct. If we just assume it must be maybe some of the scalar quantity is base quantity. All base quantities are scalar quantity. So the inverse relationship is not always the truth. Okay, vector quantity. Okay, so derived quantity, yes. Almost all vector quantities are derived quantities, except for displacement. So again, this one is correct. So hopefully that in the exam, you must think very deeply and spend 1.5 minutes to answer this question, at most 1.5 minutes. So let's move on quickly to the next question. Number 2, still in the intro Form 4. Systematic error is caused by, so if we have systematic error, it's due to the system, basically measuring instrument. If we have random error, then it's due to human environment. Okay, so we know that the systematic error is due to the measuring instrument itself, so probably 0 error. And then the malfunction of the instrument itself. So position of the eye is actually random error. Instrument use, yes, caused by instrument. Mistake in the measuring is human error due to random error. Change in the surrounding temperature is also random error. So the answer is D. So number 3, we moving on to F and M, force and motion, the most frequent topic that one of us in the SPM paper 1. This is about linear motion. Now again, one shows the position of 4 points marked on the floor. A student is asked to move from point P to S through Q and R. P to S, P to S to Q and R. Okay, which of the plane represents the displacement of the student. So it must start from P to S. So S is the final, P is the initial. Regardless of Q and R, the displacement is actually final minus initial, so SP or PS. So A, the answer is A. We just need the shortest distance between final and initial, which is this side over here. It cannot be PQS. PQS is quite long. PRS also kind of have the same distance as PQS. And PQRS is the longest one. So all of this is wrong. It must be the shortest distance. So that is the displacement, shortest distance. Or final minus initial. Okay, next question, number 4. Diagram 2 shows a displacement time graph. So this is force and motion, linear motion graph. Motion graph. Linear motion graph. Okay, so what is the velocity of the toy car? So we given displacement and time. So basically what we can extract information based on the gradient, which is velocity. So how we know that the gradient represents the velocity? So the velocity is actually y over x. Y is s. X is p. So this is the formula for velocity. Or we can compare the unit. So meter per second. So ms -1. So all of these are equivalent, represent velocity. So we can calculate gradient. And what about area under the graph? So for displacement time, the area under the graph doesn't have any significant physical quantity. So basically, if you want to calculate the area under the graph, it's just displacement times time. So what does that mean? It doesn't have any significant importance. So we don't need to make it hard to think about the area under the graph. We just need to think about gradient. So what is the velocity of the car? If you can see that this region over here, it doesn't move. So it at rest now. The toy car is at rest for this whole period of time. So it's only have a velocity at this period of time. So we can calculate the gradient for this particular part. So velocity equal to 3.0 minus 0 divided by 2.0 minus 0. So this is meter, this is second. So 3 divided by 2 is 1.5 meter per second. So the answer is A. So why this toy car is at rest at this region? Because the displacement doesn't change, it doesn't move. Or we can say that the gradient at this line is 0. So at rest means that the velocity is 0. Because of the horizontal line, the gradient is 0. Okay, so let's move on to the next question. Diagram 3 shows a man jerking a tablecloth. Okay, the situation is explained by, so basically this is a typical situation involving inertia. So what happened is that this glass over here doesn't follow with the tablecloth. So the glass stay on the table due to inertia, the tendency of an object to remain at rest or moving with constant velocity. So in this case here, what are the Newton's law that describe inertia? It's basically the Newton's first law of motion. So Newton's second law is F equal to ma. Principal conservation of energy is not really related to this case, and conservation of momentum must have collision or explosion in order to explain the principle. So principal conservation energy must have changes in terms of the energy from gravitational to kinetic or elastic to kinetic or whatever the changes that you can see. So Newton's first law is the correct one here. Okay, next, number 6, diagram 4 shows a toy pistol. A bullet is shot out at velocity v from the pistol, so there is momentum. So whenever you see a bullet or a rifle, there must be momentum question, probably principle conservation of momentum. What is the velocity of v? So this is a typical explosion problem. So basically the initial momentum is 0, the total momentum, because both pistol and the bullet are at rest, thus doesn't have any momentum for both. But at the end, the pistol has a velocity and the bullet also has a velocity as well. So we say that both has momentum but opposite to each other in order to make it 0. So we can rearrange this formula. Basically, we want this side over here. So VB equal to minus MP VP divided by MB. Okay, so minus MP, mass of the pistol is 0.1. Velocity of the pistol is negative because of the left direction. So negative 0.05 divided by mass of bullet is 0.01. So we plug in that into calculator. Minus 0.1 times minus 0.05 divided by minus 0.01, 0.5 meter per second. Okay, so the answer is C. Number 7, diagram 5 shows a car accelerating on the highway. So when the car accelerating, it must have force, net force, towards the direction of the acceleration. So the net force acting on the car is, so this is force in motion, topic force, F equal to ma. So the direction of the force must be the same as the direction of acceleration. So the net force is actually P minus R. So here. And how I know that is P minus R, not P plus R or something else, because P is in the positive direction to the right and R is the negative direction to the left. So we have to deduct the force, and the net force is actually in the direction of the P as well as the acceleration. Okay, next, diagram 6 shows a parachutist landed safely when the parachute was functioning well. What is the factor that affects this situation? So this is impulsive force. Because we have landed keyword there, then probably we have impulsive force. Collision also including impulsive force as well. What is the factors? The change of momentum is big, wrong. So impulsive force has the formula like this, or F equal to impulse J over T. J is the impulse, T is the time of impact or impact time. So if you see that the change, if the change of momentum is big, so this is the change of momentum. If this big, this whole thing over here big value, then the impulsive force gonna be larger. So it cannot be safely landed. So A is wrong. The change of velocity is big. So this is the same meaning as the change of momentum. So wrong, because V and U is the change of velocity. So we can factorize mass. So it becomes V minus U over V. So this is the change of velocity. It's still the same. It's directly proportional. The time of landing is longer. Okay, this one, either of the three, if we want to make it the time longer, then the force must be reduced because the inverse relationship. The higher the time, the smaller the force. So this is true. Acceleration is big, so acceleration is actually this thing over here. So F equal to ma because v minus u over t is acceleration. So acceleration big, force is big. So this is wrong. So the answer is C. We want basically to reduce impulsive force. Okay, number 9, force and motion safety features. Safety features. Which safety feature will reduce the risk of neck injury of a passenger if a car is hit from the back? So basically, if it's hit from the back, the car will stop suddenly, and then our neck will be moved towards the back. So it's not padded dashboard. It's not inflatable airbag. This is collision to the front. Shatterproof widescreen glass also collision to the front. So basically, it's headrest. It prevent our neck from falling towards the backwards excessively. That can cause damage to the neck. So it just stop the neck when it happens. So the answer is A. Number 10, a mangosteen falls from a tree. Which physical quantity remains constant? So this is force and motion, free fall. So force, physical quantity remains constant is basically gravitational acceleration. So not velocity, velocity increasing, acceleration constant, kinetic energy increasing because velocity increasing, gravitational potential energy decreasing. So B. Because the GPE is decreasing due to the height is decreasing as well. Number 11, okay, this is very hot question. Forces in equilibrium. So let's answer it very carefully. Diagram 7 shows a stationary. Okay, whenever we see stationary, meaning at rest, means that acceleration is 0, meaning forces in equilibrium. So net force is 0, F net is 0. Okay, on an inclined plane. So based on this question, based on this word here, stationary, we can use many things here. Okay, the box will not move when, so basically this is the situation, right? The box will not move when the net force is 0, because when the net force is 0, MA, mass cannot be 0, right? So A must be 0. So A must be 0, then that's mean either velocity 0 or velocity constant. But in this case, velocity 0, then A at rest. Okay, so the box not move. So what should we do in order to make the net force 0? So we can compare this direction and this direction. So perpendicular to each other. So if we want to compare in this direction, if this is positive, that means that the friction and the forward force must be the same. So Fr must be the same as Fc. And then don't forget that we also have to include the component of the weight itself. So the component of the weight is actually W sine W sine theta. That is in the same direction as the force here. And then this is the first comparison. The second comparison is the perpendicular one. Normal force must be the same as this component over here. Basically, what we compared before is this one. This one must be included with this, and this one must be included in the direction of the normal force. This is W cosine theta. Okay. So y is cosine, y is sine. So if we look at the diagram, this is the W, this is theta, right? So theta here with this line over here is adjacent to each other. So cos theta is adjacent over of hypotenuse, sorry, hypotenuse. So hypotenuse is the weight, so adjacent. So we need the adjacent. This is opposite, right? So adjacent here, h time cos theta, w time cos theta. So this is correct. And then this over here is opposite, so sine theta, opposite over adjacent. So not opposite over hypotenuse, basically the weight. So if we want to bring that to here, then it become w sine theta equal to the opposite force. So this must be plus, this must be n equal to w cos theta. So w here is actually mg. So n equal to mg is wrong. It must be n equal to mg cos theta. Fr equal to mg also wrong. Fr plus mg sin theta equal to fc. N equal to mg sin theta, n equal to mg cos theta, so wrong. Fr equal to fc, okay, that's correct. If we if this term over here is already included in the Fr, and n equal to mg cos theta, basically right as well, because n equal to mg cos theta over here. So D is the correct one. Okay, so again, this question is really hard. You must understand the concept of cos and sine and when to use it. And then the concept of net force, the concept of forces equilibrium. So there's so much thing happens. Okay, number 12, force and motion, work done. Diagram 8 shows Ahmad pushes a lawnmower. The force exerted by Ahmad on the lawnmower is 150 Newton and it moves with distance 90 meters. What is the work done by the lawnmower? So work done is force time displacement. So the force here, the definition of the true definition of the work done is actually the force acted in the same direction as the displacement. So the force is the product of force that acted the same direction of the displacement with the displacement. So that is the definition of the work done. So the force must be same direction. In this case, the lawnmower moving in this direction, right, to the left. The force is actually slightly slanted downward, so it has angle. So what we should do, we should take the component of the force that actually the same direction as the movement. So we have 32 degree here. If we use our math knowledge, this is Z here, this is parallel, so this must be 32 as well. So this force relationship with this force is adjacent. So again, if we see adjacent, we must use cos theta. So W equal to Fs, W equal to F cos theta S, or Fs cos theta. So it doesn't matter because multiplication can be interchangeable, the position. So the force is actually how many? 150 Newton. S is 90 meter. Cos theta is 32 degree. So if we plug in that into the calculator, we get 1144,865 joule. So this is not the answer, this is not the answer, this is the correct answer, this is not the answer. What happens if we don't include the cos theta? The work done gonna be higher. The value is gonna be higher. So basically 150 times 90, it becomes 13,500. So this one is wrong because not all the forces are doing the work. This is the trivial concept over here. Even though we push a little bit larger force, but actually not all the forces contribute towards the work done. Only part of the force that actually do the work, which of the force is basically the same direction as the the movement, the displacement. So if the force has the same direction, then we can say that that portion of the force do the work, whereas the rest probably just wasted. Okay, so let's move on to the number 13. This is force and motion, elasticity. Diagram 9 shows the arrangement of spring used by a mother when her child gaining in weight. So gaining in weight, that means increasing force. So the spring must be should be stiffer, but in this case, the mother add more arrangement to the spring in parallel arrangement. Basically, what we do for parallel arrangement, we increase diameter chord. So that's what we do actually. We increase the diameter, overall diameter of the coil. Okay, why parallel spring arrangement is used? Increase stiffness, because higher diameter, higher thickness. Increase elasticity, wrong. Increase extension, wrong. Increase oscillation, wrong. So if you want to increase oscillation, it must be elastic, because the ability to return to its original state is higher. So that is elastic. The answer is E. Number 40. So this is force and pressure. So pressure. Diagram 10 shows two types of excavator, the standard excavator and amphibian excavator. Why does amphibian excavator have wider wheel? Because we know that if we increase the area, so pressure is force over area, normal force over area. So we increase the area, pressure is reduced. So because on both excavator might be heavy, right? So we don't want it to be deep into the soil. So we want it to be able to move without any difficulties on wet soil or damp soil. So we want the pressure to be reduced, so not increase. Decrease the pressure, yes. Increase the weight, no. Decrease the weight, no. Doesn't have any significant changes towards the weight, even though it's bigger, but actually the weight changes not that important here. So the answer is B. Number 15. Diagram 11 shows a tank placed on a hill. So this force and pressure in liquid. The reading of a pressure meter at X is 5 times 0 times 10 to the power of 5 Pascal, and the density of water is 1000 kilogram meter cube per meter cube. Okay, what is the value of H? So this is again pressure in liquid. So we have closed container over here, so we don't need to take account atmospheric pressure. If this container here is open, then you must include the atmospheric pressure, but in this case you don't need to. So the formula is rho GH. Rho is 1000, G is 10, H is what we need to find. P is 5.0 times 10 to the power of 5. So if we plug in that into calculator, or we rearrange, H equal to P over rho G, 5.0 times 10 to the power of 5, 1000 times 10. So this is how many zeros? 1, 2, 3, 4. So we just reduce into 1. If we do mental calculation over here. So it becomes 5 times 10, 50, or 5 times 10 to the power of 1. So we don't really need calculator here if you smart enough to do mental calculation. 16. Diagram graph shows a balloon is connected to a manometer to measure its pressure. So this force and pressure, gas pressure or atmospheric pressure. What is the pressure of the balloon? So we have open space here, so it must be P atm here. Again, if you see open space, then you must include atmospheric pressure. So this is the P gas. So if we compare these two, which one should be higher? Compare between atmospheric pressure and gas pressure. So gas pressure seems stronger because the gas pressure can push this mercury over here to against the atmospheric pressure to fight the atmospheric pressure that also push downwards over here. So we see that this gas pressure over here is higher. So P gas is higher than P atm. So we should add P atm plus rho G H. So if higher than we add, if lower than we minus, we deduct. Okay, this is the formula. P atm is 76 given plus rho GH. So basically we just add H here because rho and G is included in the mercury. Okay, so the H is actually 8 cm minus 6 cm, 2 cm. 2 cm becomes 78 cm mercury. Okay, so the answer is D. Number 17, Pascal Principle. Okay, diagram 13 shows a hydraulic jack being used to lift a car. Typical application of Pascal Principle. Which modification needs to be made to lift heavier car? So increase surface area A1, no. We need to actually increase surface area A2. Decrease surface area A2, no. We need to increase. Increase surface area A2, yes. Decrease surface area both, no. So the answer is C. So why we need to increase surface area 2? So let's do this over here. So this is basically the simplest form of Pascal principle. The pressure at 1 must be equal to pressure at 2. So formula for pressure is F over A. So we want F2, right? So F2 is the weight of the car. So F1, A1 times A2. So again, if we assume that force is going to be constant, so what happened is actually F2 equal to F1 A2 over A1. So we want the ratio here must be bigger. What should we do? We should increase A2 or we should decrease A1. So either 2 or either 1. We can both both changes, A2 higher, A1 lower, or just either one of the changes can make the F2 higher. So in this case, we have to increase A2. So the answer is C. 18, Archimedes Principle. This one should be confusing sometimes, but let's see the question first. Diagram 14 shows a swimmer floating on the surface of water. Which pair of force and principle are correct? Pair of force and principle. So what are the forces? Up and downwards. So it's the buoyant force. This is the weight. And the principle is already Archimedes. So let's do that first. Buoyant force, weight and buoyant force. So this is not pair of forces. This is a pair of forces. So the answer is D. Number 19, Bernoulli. So we have the word Bernoulli in the question, so this must be Bernoulli Principle. Which comparison is correct about the level of water in column S, T, and U? So here the flow of air is lower, the speed is lower. Here the speed is higher. This one lower than this. Okay. Because of due to heat loss or energy loss. So even though the size of the opening is the same, but we assume that this must be lower in speed compared to the original due to loss, friction or heat loss at the middle here. So Bernoulli principle stated that the higher the velocity, the lower the pressure, or the lower the velocity, the higher the pressure. So if V low here, the pressure high. This one pressure low, this one pressure a little bit lower than the original, so we say medium, pressure medium. Okay, so if the pressure high, it can push the water higher depth. If the pressure low, it only can push lower depth. Can push smaller water, and then this one medium. So the water should be look like this. Okay, water level. S is the highest. Is it true? No. Lowest, yes. Moderate, no. Lowest, yes. T is the highest. Highest. U is moderate. So the answer is B. Number 20. Diagram 16 shows a man sits near a campfire in an igloo to warm up his body. So this is heat thermal equilibrium. What will happen when thermal equilibrium is achieved? So this is very popular question for thermal equilibrium. The body temperature increases. We don't know about that. Body temperature usually stay constant for humans, so it not will be increases. Or if your body temperature increases, that means that you have a fever or something. The air temperature inside the igloo decreases. Wrong. The air temperature should be increases. Net heat flow is from the air inside the igloo to the man's body. Wrong. It should be from the campfire towards the man's body, but it says net, right? So the net heat flow is 0. So we don't have any preference of flow. Net, when you ever see net, that must be 0 for thermal equilibrium. If don't have the word net, then this is probably true. Air, from air to the man's body. If doesn't reach thermal equilibrium yet. But in this case, if it has the only the word heat flow without the net, we can say that the air inside the igloo and the man's body are the same. The heat flow between the two are the same. Thus, there is no net heat flow. No net heat flow. Yes, this is correct. No net heat flow. Yeah, I don't need to read all of it because whenever I see no net heat flow or net heat flow 0, that means thermal equilibrium. Or heat flow is the same without the word net here. Okay, number 21, specific heat capacity. Diagram 17 shows a balloon filled with water is brought to the burning candle. The balloon does not blow up even when it touches the flame. Which statement is correct to explain this situation? Okay, why? Why the balloon doesn't melt or something, burn or something like that? Because the heat is used to heat up the water in the balloon. And the water in the balloon must be higher specific heat capacity. We already know that water is typically special because due to its higher specific heat capacity, it can store more heat. So it takes longer time for the water to increase the temperature of the water. Thus, the balloon is safer here. The balloon doesn't experience any changes towards the temperature, thus it doesn't blow out. So water is good heat conductor, wrong. The balloon is good heat conductor, wrong. Water has high specific heat capacity, yes. Balloon has low specific heat capacity, true, but it's not gonna explain the no, this is wrong because balloon has a high specific capacity as well, but it's not as high as water. Lower specific capacity is true. So the answer is C. It's not the low. Low usually used for metal, but balloon has lower specific heat capacity than water. That is true. Okay. Next, specific latent heat. You see heating curve over here. Diagram 18 shows temperature time graph of substance P with a mass of 0.025 kilogram. Okay, so it has heater, so we can use the formula Pt equal to ml or Pt equal to mc theta if the question asks for different region of the graph, but usually I think it's gonna be the Pt equal to ml because what is the specific latent heat of fusion here? So again, the question already asked us about specific heat capacity before, so we must be assume that this question should be specific latent heat. So we can reduce the possibility to use this formula over here. So if we use this one, fusion means from solid to liquid. So here solid plus liquid. So that must be this region over here where the temperature is constant. So if you want to use that formula, so L F equal to Pt over M. So the power is 1000. Time is 90 minus 50. 90 minus 50 divided by the mass is 0.025. Plugging that into the calculator, 0.025, we got 160,000. Oh, extra zero, we don't need that. Joule, not joule, this is, yes, joule per kilogram. So how many zeros here? Because it's in the standard form. 1, 2, 3, 4, 5 zeros. So from basically all of this is on 5 to the power of 5. So the answer is A. Okay. So if the question asks for specific region like this one, solid, right? So then you have to use the MC theta because we have temperature difference. If the answer is in this region, then we don't need the MC theta. We just plug in the values to find the respective physical quantities. Okay, next, number 23. This must be gas law, heat gas law. So which gas law? Pressure law. So if we remember back our triangle here, pasti boleh cemerlang, right? So it given us an extreme desert crossing race started before dawn. Dawn means subuh during that time at temperature of 2 degrees Celsius. So we have temperature, the pressure, then we have pressure. So these two both quantities are marked. That means we have to use the pressure law. So the pressure is here. What is pressure in each tire at noon? Noon is a little bit higher temperature, 45 degrees Celsius. the volume remain constant. So again, volume is constant, P. So P1, T1 equal to P2, T2. It asks us about pressure at noon, right? So we must bring T2 here. So P2 equal to P1, T1 times T2. Make sure that your temperature must be in Kelvin. So I repeat again, in Kelvin at 273. Always forget, don't forget that. Whenever you see temperature, you must think a while. Do I need to change it into Kelvin? Don't just plug in the temperature. Same like the question before, the MC theta, for example. Do you need to change into Kelvin? Yes or no? Because if you do change the temperature in Kelvin, you also gonna get the same answer. If you don't change the Kelvin into Kelvin, temperature into Kelvin, you also gotta get the same answer as well. So that's the special case of differences when we do minus subtraction. If the two units are the same, then the answer gonna be the same. But if we have ratio, division, or multiplication, if we don't change the unit, it's gonna be the different. The answer gonna be different. It's gonna be the different for Celsius, it's gonna be different for Kelvin. But we know that in order to use gases law, we must use absolute temperature because the graph, the directly proportional graph, is actually for absolute temperature. If we use degree Celsius for the temperature, the graph is actually linearly increasing. So we cannot use ratio. We must use y equal to mx plus c or something like that. If we want to use ratio, then we just need to eliminate the y-intercept, which means that we use the absolute temperature, which the y-intercept is 0. So in this case, make sure that you change temperature into Kelvin. So I repeat many times for you to memorize it, to remember. It's not that hard to change into Kelvin though. Just add 273. It's not that hard as well. 5 divided by 2 plus 273 times 45 plus 273. So we will get 418.18 Pascal. So how many? Because the answer should be in the standard form. 1, 2, 3, 4, 5. So it must be to the power 5. So 4.39 here. So again, remember that temperature must be in Kelvin, regardless of anything, except for MC theta, you can do both. Celsius also fine, Kelvin also fine. But for gases law, always in Kelvin. Okay, so this one is light refraction because we have water here. Diagram 19 shows a glass of water being placed in front of a piece of black and white paper. Okay, the situation explains the phenomenon of, we see that the color is a little bit weirder. This one doesn't have water, this one have water, right? So the one that has water causes the paper to flip, the color flip. So this is due to the band of light. Band of light means refraction of light. So the answer should be refraction of light here. Okay, next, 25. Diagram 20 shows the path of light ray that pass through two mediums of refractive index, M1 and M2, which pair produces total internal reflection. So total internal reflection has two conditions. The first one, from least, or not least, from densest to least. From densest to least densest, densest to least. That is the first condition. And then I greater than C. The incidence angle must be greater than the critical angle. So based on these two, M1 and M2, which of the medium is the densest? Which one is the least? We see the angle here. The angle is away or towards normal. So in this case, the value of r is greater than I, that means it's away from normal. Away from normal, that means the speed is higher. Speed of light is higher at this region. That means it's least densest, least dense. Whereas N2 must be densest. So this is N2, this is M1. It must be from N2 to M1. So incidence angle over here, we say that it must be greater. Refractive index, N2 greater than M1. N2 greater than M1 and N2. M1 is wrong. So that is B. Number 26. An object with a height of 3 cm is 50 convex. So this topic lenses, convex lenses. A sharp image is formed on the screen. The cm convex lens. What is the height of the image? So this is quite complicated, but we need to the formula here. So what are the formula? 3 cm plus 15 cm. So this is basically the magnification formula. So this is V is the image distance, U is the object distance, or we can replace it by height of image, height of object. So we can use this two ratio here. V image distance, image distance is 30 cm from the convex lens. Object distance is 15 cm. Height of image is what we need to find for. Height of object is 3 cm. So height of image is actually 13 over 15 times 3. 13 over 15, 2. 2 times 3 is 6. So that is okay. That's all for today because number 36 is topic 1.5. So we will continue that later, and this video is already long. Make sure that you understand all the concepts that being asked in this question paper and know which formula that you have to use in order to answer calculation question, and remember the laws, the principles, and the all the concepts that relevant to Form 4 topics. Okay, see you soon tomorrow. Thank you.